Alright guys, today we're starting something new, and we are learning about the law of sines and cosines, which are just two different formulas that we can use to help us solve any type of triangle. So up until this point, we've only been able to solve right triangles. So these are going to help us with what we call oblique triangles, which are basically triangles that are not right triangles. So to start off, we're just going to look at what the law of cosines is. And the formula is down here. It is c squared equals a squared plus b squared minus 2ab cosine c. Now if you guys remember, when I have a triangle, the big letters represent the angles, and the small letters represent the side across from that angle. Now what's really nice about the law of cosines, if you think about this, let's say this was a right triangle, and let's say I plug in some values into this formula. No matter what a and b are, if I take the cosine of c, and if c is my right angle, we know that the cosine of 90 is 0. So whenever I would work that out, if that c was a 90-degree angle, all of that would cancel out, and that should look pretty familiar to you guys as a formula for right triangles. Now, we're only going to look at the formula written this way, but what's important to realize on this is you can use this formula, you can interchange these letters in different places. What's really important though is no matter when you use it, the side that's isolated by itself needs to be the side across from the angle that you're taking the cosine of. So those letters can be anything as long as the first letter and the last letter are the same. So if I wanted to, this would be the same thing as a squared is equal to b squared plus, let's just throw another, let's use k squared minus 2bk cosine a. So it doesn't matter what letters you use, again, as long as those first and last ones are the same. So the side that's squared by itself needs to be across from the angle you're taking the cosine of, and then your other two sides just go in the other places. So let's actually try an example of this. We're going to use the law of cosines to solve this triangle down here, and we're going to use that to find side xz. So again, xz is the side across from the 39-degree angle. So that means let's call that y, because it's across from angle y. So we're going to fill in this formula. The side that's by itself needs to be the one that's across from the angle I'm taking the cosine of. So if I put y squared over here by itself, then I'll have 5 squared plus 7 squared, the order doesn't matter, minus 2 times b times my other side, and then it's times the cosine of the angle across from the side by itself, and that angle is 39 degrees. So then at this point it's actually really, really simple. All I need to do is type all of that in my calculator, and I'm going to get my answer. Now I would suggest putting all of this in the calculator at one step and then taking the square root just to make sure you're okay with parentheses. But however you do it, at this point you're just finding your answer. But the biggest thing to realize is that, remember, that is a y squared. So I do need to take the square root of everything over there. But once I've typed that in the calculator, I should get an answer for y of 4.43. And if you guys think about this, that makes sense because 39 degrees is a pretty small angle, and 4.43 would be my smallest side. Alright, so we're going to look at one more example, another way we can use the law of cosines. This one's going to be a little bit tougher. But let's say I want to solve for the measure of angle B, and it gives me 3 sides. Remember, the small letters are sides. So I'm going to go ahead and draw this triangle to start off with. Alright, so I know 3 of my sides. It doesn't matter how I draw the triangle. I'm just going to label it A, B, and C, and I'm going to put those sides on there. 9 is across from angle A, 7 is across from angle B, and 3 is across from C. And I'm trying to find angle B. So what that means for me is that when I set up my law of cosines, the 7 has to be by itself, because that's across from the angle I'm looking for. So 7 squared equals 3 squared plus 9 squared minus 2 times 3 times 9 times the cosine of the angle across from 7, which is b, which I don't know. So the only reason I'm a little bit tricky because it's a little bit harder to solve for. But since we've been solving inverse equations, this shouldn't be too difficult. If you guys remember, whenever I solve inverses, everything that's with that cosine, I'm going to have to leave until the end. So the first things I'll need to get rid of are the 3 squared and the 9 squared. And I can just subtract that. So I'm going to subtract whatever 9 plus 81 is, which is 90. So I'm going to subtract that from both sides. So what that's going to give me is, on my left side now, I'm going to have a negative 41, and that's going to equal, I still have that negative sign, 2 times 3 times 9. I'm going to go ahead and write actually what that is, and that is going to be a negative 54. So now, just like when I solved those inverses, I need to get the cosine of b by itself, which means I need to divide by negative 54. So now I know that 41 over 54 is equal to the cosine of b. And at this point, hopefully this is pretty simple because we've seen these a lot now. The only way to get angle b by itself is to rewrite this function as an inverse. So in order to find angle b, what I'll type in my calculator is cosine inverse of 41 over 54. And that's going to tell me the measure of angle b. Now make sure your calculator is in degrees because we are solving these actual triangles. We are going to measure all of these in degrees. So this entire unit, make sure you have the right mode. And we'll round our degrees to the nearest whole number. So the measure of angle b ends up being 41 degrees. So that's all there is for the law of cosines. Later on this week we're going to look at the law of sines, which is going to help us figure out ways to solve a few more triangles.